Hello everybody and welcome. I am Cătălin Tudose. I am a Java champion and I'm currently active as a Java and web technologies expert and a Java chapter lead in Luxoft, Romania. Our discussion today is about effective transactions management with Spring. A few more things about me. I am the author of these two books that were published at Manning. JUnit in Action was published in November 2020, and Java Persistence with Spring Data and Hibernate was published in January 2023. The topic of today is related, of course, to Java persistence. To introduce you or to remind you about the important things about transactions, our main topic from today. What is a transaction? A transaction is a group of operations that are having the ACID properties. ACID is an acronym from atomicity, consistency, isolation, and durability. Atomicity means that either all actions occur or nothing occurs. To provide you a real-life situation, you want to transfer some money from one account to another account. This operation can be split into extracting the money and putting the money on the other side. If one of these steps is failing, then the whole transaction is failing. For example, you may try to extract some money from the first account and you do not have enough money. Then the money will come back and the transaction is set to be rolled back. Or you extract that amount from the first account, it's a successful operation, and you go to the other side and you found out that the account is blocked. So the money will not vanish, but the whole transaction will be rolled back. This is atomicity, is all or nothing. Consistency means once a transaction has completed, successfully or not, the data is in a consistent state. Isolation will mean that each transaction should be isolated from others in order to prevent data corruption. And we are going to discuss pretty much about levels of isolation in our demonstration. And durability, once a transaction was completed, its result should be durable. There are some problems that such transactions may generate. The most important problem, and that always has to be avoided, is the lost update. We are going to provide here several examples about concurrent transactions, and we are asking ourselves about the level of isolation between them. Lost update will mean I have two concurrent transactions, and here first transaction will say, okay, let me look at the buy now price. We are talking about an auction, and for some objects that are given for that auction, we are having some buy price. And let's say that the first transaction reads the buy now price as value 10. The other transaction that is concurrent will say, okay, the buy now price is 10 and I will increase this buy now price because I'm providing another offer. It's 12. The first transaction will continue and will say, oh, I know that the last buy price is 10, so I will increase it to 11. This one will update the buy now price to 11. The second transaction will update to 12. And you see that we have two operations from two different transactions, increase with 1 or increase with 2, and overall one of the operations is lost. This is the lost update problem, and it should never occur in a database. But there are also other problems. Dirty read. Again, we are having two concurrent transactions. The first transaction will say, okay, I would like to update the highest bid to 110. And I am checking that the auctioneer has enough funds. Meantime, the second transaction will read and will see okay, we are having the highest bid is 110. Transaction 1 will roll back the highest bid because it finds out that the auctioneer does not have enough funds. This is a dirty read because the second transaction has read 110, which then was rolled back by the first transaction. Unrepeatable read means the following. We have again two concurrent transactions. The first transaction will say which is the highest bid. It's 100. Meantime, the second transaction will increase the highest bid to 110 and will commit. Then the first transaction will say, okay, I have read the highest bid 100. I come here with auction 105, but I have to roll back because my read was not correct, is unrepeatable, and some other transaction meantime changed the highest bid. And phantom reading, again, we have two concurrent transactions. The first one will say, how many bids are here for this item? 2. Another transaction will insert a new bid for the same item. So it will add something in a different row and will commit. The first transaction will now have how many bids for the item? 3. This is a phantom reading because meantime, during the execution of the first transaction, something happened, but not with a particular existing row, but by adding a new row to the same table. So these are the problems that may occur in transactions, and we have to think about what we can do, what we can avoid, in which conditions should we avoid some problems. We're saying that the most important problem is the lost update, and it should never ever happen. Okay, let's have a look at different transaction isolation levels. We have enumerated a series of 4 problems: lost update, dirty read, unrepeatable read, and phantom reading. And we see here that they are addressed by different isolation levels: read uncommitted, read committed, repeatable read, and serializable. You see here that when in our table we have a plus, it means that that isolation level will address that problem. For example, the lost update problem has a plus in front of it, no matter which the isolation level is. So we were saying that the lost update problem is the most important problem, and we should always address it. So the read uncommitted isolation level will address the lost update problem, but will not address the other ones: dirty read, unrepeatable read, and phantom reading. And if we look on the right hand side, we see here that we ask ourselves, we have some transaction, let's call it transaction number 1, and we are asking ourselves which is the interaction with some other transaction. Let's call it transaction number 2. Of course, it depends on the isolation level. So if transaction number 1 has isolation level read uncommitted, as for our first row here, what are we saying here? So if it is doing a reading, there is no lock. So both transactions can read freely. If, however, my transaction number 1 is writing, the second transaction is locked, but only from writing. So I'm updating some row with transaction 1. Some other transaction can read that updated row, including some uncommitted read. That is why the isolation level is called read uncommitted, but will not be able to write to the same row in order to avoid the lost update. Okay, the next isolation level is read committed. My transaction number 1 is doing a reading. Transaction number two can do either a reading or a writing. There is no lock. But if my transaction number one is doing a writing, the second transaction number two, will be locked both from reading and from writing, as we see here. So it is only after having committed from the first transaction that we can read or write from the second transaction. This way we avoid both the lost update and the dirty read problems. We'll say here that in most situations, the read committed isolation level is the default isolation level by many databases. If you do not specify any particular isolation level, then the read committed will be the default one. The next isolation level is repeatable read. It will say if my transaction number one is reading, some other transaction may read but may not write. Of course, if my transaction number one is writing, the second transaction is locked both from reading and from writing. So I do not want to have some unrepeatable read. If I am reading, I am blocking other transactions from writing so that if I read again, the unrepeatable read does not happen. And the highest isolation level is the serializable one. You see here that it addresses everything from lost update, dirty read, unrepeatable read, and phantom reading. No matter what I do from transaction number one against the database, the whole table is locked from read and write from another transaction. This is the safest one. As long as I'm doing something from transaction number one, then everything is blocked until I commit or roll back transaction number one. Now, one idea that you may ask yourselves is, okay, if everything is so safe from the serializable isolation level, why shouldn't we use it by default? The answer is that the highest isolation level is, the highest the overhead is. So serializable will mean that you have one transaction after the other, and every transaction will wait for all other transactions in front of it to fully finish so that it can access the database and do its own job. So this may bring to very high waiting times. In a real system, this is absolutely unpractical. Imagine that you want to access some system that is dealing with tickets for a concert or for some event. If the transactions are serializable, then you will have to wait in a row for all other transactions in front of you, no matter what they do in the database. This will bring to high waiting times and will make the system unpractical. But if you admit some lower isolation level, yes, it may happen that you start picking up some tickets, put them in the basket, go to the payment, and then you are rolled back because some other transaction was quicker and it picked up the same tickets. This is, yes, unpleasant, but it is much more practical than having everything fully isolated through the serializable isolation level. In order to make our demonstration, we have prepared this application. It is interacting with a database, and you see here that we are having this item entity. You see that it is a class that is annotated with entity. Table, it means that it is corresponding to some table in the database. And we have also used this ID and generated value annotations. This means that this is the ID, the primary key. We don't have to specifically deal with its value, but it is a generated value, so it is the database that will take care of it. These other fields are also database columns, and they have some corresponding column in the database. We use these getter, setter, annotations, no args constructor that are belonging to the Lombok library. Lombok is a library that is helping us avoiding some boilerplate code like constructor, getter, and setters. We have also created this log entity. Again, we have annotated it with entity. It means that it has some corresponding class in the database. This field is annotated with ID. It's a primary key, generated value. The value is managed by the database itself. We have some other fields here. And of course, we are using the Lombok annotations, no arg constructor, getter, setter. In order to manage these items, we created here some repositories. You see here my repository, item repository extends JPA repository of item and long, plus this item repository custom. Yes, we are defining here some customary methods. But as this item repository is extending JPA repository, it means that if JPA repository is generified by item and long, this item repository takes care of managing entities of type item having primary keys of type long. If I go here in JPA repository, I will see that I am inheriting a big list of methods here. All these methods are not implemented anyway. I just need to extend this JPA repository through my repository, and Spring data will understand, yes, your intention is to manage entities of type item having keys of type long, and it will create the implementation of all these things. For example, find all will mean select all from item, and that is all. The Java code that will correspond to the SQL select all from item. All these things are automatically implemented through a proxy class that is created by Spring. For example, this get by ID will be translated in some method that will correspond to select all from, which is T is item, select all from item, where ID equals this parameter, and so on. Plus, as we are also extending our own custom class, we have here this implementation, and it is compulsory that I have it with this IMPL end. It will understand Spring data that this is the implementation, and it will create this item repository that will have also this check duplicate name, which is transaction, add item, no rollback, and so on. The same is true in the case of this log repository that is extending JPA repository of log and long, means that I am managing here entities of type log having keys of type long, and I am also adding the implementations from here, from log repository custom, so from this log repository IMPL. So just like in the case of this item repository, also in the case of this log repository, Spring will provide a proxy class that will have all the methods from JPA repository implemented, plus the ones from log repository IMPL. And now let's test our application. We prepared here some tests And we'll have some look at what we are doing here. We have to introduce the transactional method, the transactional annotation, this transaction annotation. So it means in a declarative way that we have some transactional method. But also transactional has some parameters, among which we may use this isolation parameter. When we say here isolation equals repeatable read, it will mean that our transaction has that isolation level of repeatable read. Just what we discussed a little earlier. So let's test the execution of this method. You see that I'm having here some breakpoint. So I will right click, say debug repeatable read. Let's wait for a few seconds. We have to start querying this table. You see that I am finding the first item from this item repository, the first entity. Find all.get 0 will give me the first entity, and I'm printing the highest bit. Okay, it is running. Just a few seconds. Okay, and I see here that the highest bit is 180. This is our transaction number 1, having isolation level repeatable read. And I am launching here the second execution here, update item, that would like also to get the first entity from the item repository, increase this bit with 10, then save it. Let's see what is happening. Wait a little. Okay, our update item has read the same highest bid 180, but it cannot go further. Why? Because this transaction has isolation level repeatable read, and it will not allow this transaction to go further, to write, to save to the database, because I want my reading to be repeatable. I am during the execution of this first transaction, and if I go back here and I'm resuming it, you see I am getting the same 180 here. My reading is repeatable, so 180 once, 180 twice. Meantime, this other transaction has been released, and I was able to increase from 180 to 190. Because I keep this isolation level repeatable read, but maybe I don't want it to be so tight. So I am removing this isolation level. If I'm not having any argument here for isolation, the default one for transactional is read committed. So it is a lower one than repeatable read. Let's execute this one. Again, the same breakpoints here, remember, the same breakpoint, but we reduce the isolation level from repeatable read to read committed. I was saying that this is the default one. Let's wait for this to execute and stop here at the breakpoint. Okay, we are waiting for 190. This is the last updated value. And let me go to this update item. Remember, when I executed update item a little earlier, it was hanging because it couldn't advance as long as the first transaction was in execution. Let's see what is happening now. Remember, I reduced the isolation level from repeatable read to read committed, the default one. This transaction was able to increase from 190 to 200, unlike what it was happening previously when this one was hanging, and it committed. I come back here to this repeatable read, and I am resuming it. So the second read here provides a different value, 200 instead of 190. So I reduced the isolation level. The other transaction was able to execute and commit during the execution of this first transaction, but now I'm no longer having a repeatable read. First time I read 190, now the second time I read 200. So we demonstrate the usage of different isolation levels. But let's have another look at some other example with isolation serializable now. So this is the highest isolation level. I was saying that when we are using isolation serializable, effectively the execution of all transactions will be serialized. They will wait one after the other to fully commit. Let's execute this. So this time I am asking which is the size, how many items do I have in this repository. Okay, I'm waiting for some size to be printed. So I'm having five items I have in the list, and I want to add some other item from this other transaction that I'm executing. Remember, this isolation level is serializable. I started the execution of the add item. Let's see what's happening. So this execution is hanged here because it has to wait and wait and wait until this transaction is finalized. So let's resume it. I read here 5 items, again 5 items. Here, now this one was released. So I was able to insert another item only when this transactional serializable was finalized. But let's reduce the isolation level and re-execute this phantom read. So now I'm doing the same thing with the same debug execution. Here is the breakpoint, but the transactional isolation level is no longer serializable. The transactional isolation level is the default one, read committed. Let's wait, and of course will be blocked here in debug mode. Okay, it always takes a few seconds. Of course, we are looking for seeing the differences between the executions. What did we read here? 6. We had 5 plus the one that we added previously. Now let me add another item. What can I do here? Will this hang again? It's executing add item. This one is in debug, so this transaction is currently in execution. Let's see what's happening. Previously, this add item was blocked here to wait for the other transaction. Here, it goes to the end. You see that the test is fully executed. I go back here to the execution of this first transaction. I resume it, and you see now I no longer have the size of 6, but the size of 7. So reducing the isolation level, I allow some other transaction to write some other row in the database. And now when I am asking myself how many rows do I have in the table from the same transaction, the size is different. So you see that we can manage here easily the isolation levels through annotations, meaning through meta information. We demonstrated how these transactions may interfere depending on the isolation parameter. By simply changing here some isolation parameter, the execution is different. The code is freely available on my GitHub account. You can find it here. And of course, if you want to get in touch with me, you can easily find me here on LinkedIn, or eventually you may get in contact with me on Twitter. So we are just at the end. Thank you for being here. Thank you for watching. I'm happy that the effective transactions management with Spring is of interest for you. Remember to rate the presentation and leave the questions in the appropriate section.